Hi, my beautiful, beautiful students. Today we're going to be talking about how to graph in different forms of a quadratic equation. So we've been talking about how to graph when you're in standard form. In this section, we're going to talk about how to graph not only in factored form, which is a new form of our quadratic. We've talked about how to factor a quadratic, but we haven't talked about factored form. And then also how to graph in vertex form. Okay, so in example 1 and 2, we're going to be going over how to graph in factored form, which factor form looks like when we factor a polynomial. Okay, factors are numbers that are multiplied together to equal another number. So if you see here, I have x minus 3 times, there's secretly multiplication in between the parentheses, x minus 3 times x plus 2. So these are factors because they are multiplying together. So we're going to identify all of the same key parts that we did when we were graphing in standard form. Just this time it's going to be done a little differently since we're solving in a different form of a quadratic equation. Sounds like a blast, right? I know. So let's get started. So let's see here. Please don't freeze. Please, please. Oh, looks like it's freezing. No, don't freeze. Please. Okay, looks like maybe we're good. We're good? Okay, we're good. Sorry, guys. Okay, so we are graphing in factored form. So factored form of equation kind of looks like this. Okay, the a value is going to be the value that's right after the equal sign, just like when we're in standard form or vertex form for that matter. And then we have two parentheses or two values that contain an x that are multiplying together. Okay, so we're going to find the zeros, the y-intercept, the axis of symmetry, our vertex point, and our a value, like we did before to help us graph our beautiful parabola. Okay, so first of all, this time we're going to start by finding our zeros because when you're in factored form, it's actually pretty simple to find your zeros when you're in factored form. Guys, so when we find our zeros, those are our x-intercepts. Remember, zeros, roots, x-intercepts, solutions, they all mean the same thing. So when we find our zeros or x-intercepts, we make y0. When we find our y-intercepts, we make x0. So just be careful. Okay, so first of all, our zeros, I'm going to set y equal to 0. So I'm going to transform that y into a 0. And that will equal, so our y becomes, or hold on, yeah, y becomes 0. Sorry, so we have x minus 3. And then we have x plus 2. Okay, so if you guys see here, I have a parenthesis times another parenthesis equals 0. So that means if more than one number multiplies by 0, at least one of these has to be 0. Guys, so remember, when we're finding zeros after we factor, which guess what? We're already in factored form. After you factor, you set every single factor equal to 0. Okay, so I'm going to set x minus 3 equal to 0. And I'm also going to set x plus 2 equal to 0. So x plus 2 equals 0. All right, so you can either solve this for x, like I could, add 3 on both sides here, or subtract 2 on both sides to solve for x. Or remember, the shortcut is to flip the sign. Since the number in front of my x's, my coefficients in front of the x's, or my leading coefficient actually, is 1, you can just flip the sign. So what is the opposite of negative 3? Holy hot dog, that would be positive 3. So x could be 3, or what's the opposite of positive 2? Precisely, it would be negative 2. So x equals negative 2. Guys, so the shortcut is just to flip the sign. So guess what? We already found our zeros. And I'm going to go ahead and plot those on our nifty graph. Guys, so we have a 0 at 3. So these go on the x-axis. So I have one at 3. And then I have one at negative 2. Here we go. Okay, the next thing we're going to find is the y-intercept. So the zeros or the x-intercept is where the graph smacks the x-axis or crosses the x-axis. The y-intercept is where the graph smacks the y-axis or crosses the y-axis. So now when we find the y-intercept, we need to make x equal to 0. Now, since we are not in standard form, you can't just like pick a number on the end and call it your y-intercept. We're actually going to have to solve for the y-intercept when we're not in standard form. So just be careful. Okay, don't just start assuming things are the y-intercept in factor form. Be very careful. The demon cats are always out and about. Just saying. Okay, so I'm going to substitute and replace every single x with the 0 to solve for my y-intercept. So we found our x-intercepts. I made y 0. This time I'm going to make my x is 0 to find my y-intercept. So we're going to have y equals, my x right here is going to transform into a 0 minus 3, and then times 0 plus 2. So I've made each of these x's 0, and now we're simply going to solve. Okay, so I have y equals, well, 0 minus 3 is negative 3, and 0 plus 2 is 2. And guys, when you have two parentheses side by side, it means you multiply. So now I have negative 3 times 2, so my y-intercept is negative 3 times 2, which is negative 6. So y equals negative 6, or you could write it as a point. Technically, you could write the zeros, or the x-intercepts, as points as well. Like I could have written this as 3, 0 and negative 2, 0. So those all mean the same thing. Okay, so my y-intercept is at negative 6. So 1, 2, 3, 4, 5, 6. Eventually, I am going to reflect it over the axis of symmetry. But if you guys notice, I don't have an axis of symmetry yet. So I can't really do that. But I will do that later on. Okay, so we have our y-intercept. I'm going to abbreviate it with y-int. So I'm a mathematician and I'm lazy, right? Okay, and then these are my x-intercepts, or my zeros, or my roots, whatever you want to call them. Okay, so in order to find everything else I need to find in order to draw my beautiful parabola, okay, what I need to do is I need to convert this to standard form. Okay, which you actually already know how to convert this to standard form. You just don't even know. So it's going to be pretty cool. Okay, so I have y equals x minus 3 times x plus 2. So, do you guys remember how you get your equation from looking like something like this to standard form, which is like that ax squared plus bx plus c? Do you guys know how you solve when you have a parenthesis beside another parenthesis? I've taught you how to solve something like this. I knew you guys would remember. You guys always remember everything. Okay, so when you have a parenthesis right beside a parenthesis, what we're going to do to convert this thing to standard form is to distribute this thing out. Okay, so I'm going to start with the first term, multiply it to both of these bad boys, then move on to the second term and multiply it to both of these bad boys. All right, so I'm going to start with the x and multiply it to each term. And then I'll transition to the negative 3. Now don't forget, you guys, when you multiply variables with exponents, you must add your exponents. Okay, so x times x, well remember, if you don't see an exponent, they secretly have a 1. So x times x is 1 plus 1, which is 2. So we got 1x squared, or x squared. And then x times 2, well, those are not like terms, so you can't really multiply them. So you just kind of slide them side by side. So that would be plus 2x. And then we have, going to multiply negative 3 to both of these bad boys. So negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. And then after this, I'm just going to combine my like terms and identify the a, b, and c. Alright, I'm going to start with my x squared, which I don't have any other x squared, so guess what? I'm just going to bring it on down. Okay, my next two like terms are the two terms that contain just x to the first. Now remember, you guys, when you combine like terms, do not touch the exponents. That's when the demon cats will get you. Okay, so leave the exponents alone when you combine like terms. You only add what's in front. So 2x minus 3x, well, 2 minus 3 is negative 1x, or you can just write negative x. It's kind of up to you. So I'm going to write negative, I'm going to put the 1, why not? So negative 1x. And then my last number doesn't have a like term. It's all by itself. It's -6. So guess what? I'm just going to bring it on down. Okay, so I have standard form. Yay, doesn't that look cool? And if you guys see, now that we're in standard form, the C value is going to be your y-intercept. So if you guys see, whoa, we got -6. So that's a good way to check yourself when you convert to standard form. If you see that your C value is the same as your y-intercept, then you know you did it right, for the most part. Okay, so let me identify the A, B, and C. So my A is the number in front of the x squared, which I don't see anything, which means there's secretly a 1. Okay, the B is the number in front of the x, which is -1. And the C is the number without the x, which is the -6. Okay, so using that information now, I can find the axis of symmetry, which will help me to find my vertex point and identify my maximum or minimum. Okay, let's find the axis of symmetry. I'm excited. Okay, so we're going to do the opposite of B. So the opposite of B, the opposite of -1. Well, that would be a positive one. Like normal, you guys know. You're so smart. Okay, so 1 over 2 times A. Well, A is 1. So 2 times 1 is 2. So the axis of symmetry is x equals 1/2. Okay, and don't forget, you guys, that value is the same as your h value in your vertex point, or the x-coordinate of your vertex point. So my h value is also 1/2. Okay, so I'm going to go ahead and draw in my axis of symmetry real quickly. Okay, so this is a vertical line that will smack the x-axis at 1/2. Okay, so I know it must cross the x-axis at 1/2, so I'm going to kind of prepare myself. I'm going to draw in my beautiful axis of symmetry. Let's do it. Here we go. Okay, and don't forget, you guys, now that I have my axis of symmetry, I can reflect my y-intercept over to get another point on my parabola. So the y-intercept is only half a unit to the axis of symmetry. So the y-intercept, when I reflect it over, will be half a unit on the other side. So it's actually going to land on the 1 on the x value. So when I flip it over, I need to make sure it's kind of at the 1 on my x, which it is. So there we go. Okay, and now that I know the x value or the h value of my vertex point, now I need to find the k value. How do we find the k value or the y value of the vertex point? Correct. Okay, so I'm going to substitute in 1/2 for my x back into standard form this time. Technically, you could substitute it back into your factored form as well. It's kind of up to you. I think in this case, it'll be easier to do it in standard form though. Okay, so I'm going to replace every single x in standard form with my 1/2 to find my y value or my k value for my vertex point. Okay, so we have y equals, well, x squared, so my x is going to be 1/2. So this is 1/2 squared. And then -1 times x. So my x is going to transform into the 1/2. So times 1/2. And then -6. Okay, so remember, you guys, you could rewrite this whenever you square a number, you multiply it to itself. So you could say 1/2 times 1/2 and multiply it. Or remember the shortcut, you can just square the numerator and denominator. So 1 squared, or 1 times 1 is 1. And 2 squared, 2 times 2 is 4. So that is 1/4. Okay, and then -1 times 1/2, well, -1 times anything will make it basically the opposite of what it was. So the opposite of 1/2 is -1/2. And then -6. Okay, so before I can combine any of these, I need to have a common denominator. So I'm going to rewrite -6 to look like a fraction, so it's secretly over 1. So what do you guys think my common denominator be? What is the smallest number that 1, 2, and 4 multiply to equal? That would be a 4. Okay, so I need to make sure all of my denominators are 4. Okay, I'm going to try to squeeze it in right here to save me some steps. So 2 times what will give me 4? Well, that is a 2. So I'm going to multiply 2 to the denominator, but don't forget, you multiply it to the denominator, you got to multiply it to the numerator. Okay, and then my other fraction, 1 times what gives you 4? Well, that would be a 4. And remember, if I multiply it to the bottom, got to multiply it to the top. Okay, and then on these two, you guys, I'm just going to multiply straight on across. So multiply across. So we have y equals 1/4 minus 1 times 2 is 2 over 2 times 2 is 4. Then negative 6 times 4 is negative 24, and 1 times 4 is 4. Okay, so remember, whenever you add or subtract fractions, you do not touch the denominator. Leave the common denominator alone. Don't touch it. Okay, so my 4 is going to remain as a 4. 1 minus 2 is negative 1. Minus 25, 4 more is negative 25. Look at that. Let me just double check. Yep. So my k value, or my y value, is negative 25 over 4. Okay, which 25 over 4, I'm just going to approximate. So 4 goes into 25. Well, I know 4 times 5 is 20, and 4 times 6 is 24. Okay, and 4 times 7 is 28. So I know it's slightly over 6. So I know this is like negative 6 point something. Okay? Again, when we're graphing, we're just trying to do our best. We're just trying to make our best effort to graph as accurately as possible. So I'm going to go over to 0.5 and then like negative 6 point something. Okay? So let's graph this thing. So I'm going to go over a half. Remember, we have to land on our axis of symmetry when we plot the vertex point. So then I'm going to go down like a little bit over 6. So 1, 2, 3, 4, 5, 6. And I'm just going to go smidge over. There we go. All right, the last step is to find the A value, which tells us if it's a maximum or minimum. Which, guess what, you guys? The A value is the same in factored form as it is in standard form. Okay, so in standard form, we already said the A value is 1, which if you guys see here in factored form, the A value is still in the front, which since I don't see a number in the front, there secretly is a 1 as well. So the A value should be the same in factored form and standard form. So my A value is 1. Okay, and since A is 1, so it's a positive, which means it's greater than 0. Okay, so it's a positive graph, which means it's a happy graph, right? So it's going to have a minimum, which makes sense because if you look at the graph, it kind of looks like it's taking that shape anyways, right? All right, my favorite part. Let's plot these points and graph it, which my parabolas don't always look the best, so don't judge my graph, you guys. All right, I'm going to connect my points as best as I can. So this is our vertex point, if you want to label that. All righty, let's do it. Oh man, I completely missed that x-intercept. Please, when you draw it, like actually go through the x-intercept. That was really bad. I think the demon cats got me when I did this side. Sorry, you guys. But anyways, don't forget the very last step. We must name our graph. Your graph deserves a name. So make sure you guys name your graph. My graph's name is going to be named Isabel. So there you go. All right, example 2 is pretty much the same. So if you want to try that one on your own, I say go for it.